Okay, in the last example, we went ahead and we decided we were going to count atoms and moles of atoms. So how do we progress and take a look at finding what's called a molar mass? Molar mass. Okay, what a molar mass, it's the mass in grams of 1 mole of a substance. So again, we get this 1 mole. 1 mole is a way of representing a large number of atoms. Like I previously would say that 1 mole is equal to 6.02 times 10 to the 23rd, which is lots and lots of atoms. Okay? So really, we don't have to use that. We don't have to worry about that number. Remember, I said that's something we're not going to concern ourselves with. So, for example, if looking on the periodic table, if you have a periodic table handy, go ahead and get that out. It would be in your handbook. You can pull it up on a separate line on the computer. But anyway, or you can take my word for it. What we're looking at, for example, if we have 1 mole of carbon, C for carbon, what is that equal to in grams? Well, on the periodic table, they have this thing called atomic weight. An atomic weight represents what 1 mole is equal to. For example, carbon, the atomic weight is 12.01 grams. So, if we were looking at the periodic table and we said we got 1 mole of carbon atoms and we weighed out that number of atoms, which is this big number right here, how much it would weigh on a balance would be 12.01 grams. If I said we had 1 mole of magnesium, again, we look on the periodic table, we look for the atomic weight, and when we look up the atomic weight for magnesium, it should read 24.305. So I can kind of limit that, maybe not take it out as far. Okay, so then I'm going to have you go ahead and just take a look at doing a couple and see how they equal. So I'm going to say, what does 1 mole of nitrogen equal in grams? Right? What does 1 mole of aluminum equal in grams? So go ahead and look. Find nitrogen. There should be a atomic weight. It's a number that's a decimal. What's a decimal usually? So when you take a look at nitrogen, it would be 14.01. And that's how many grams are in a mole. Aluminum, when we look at that, go ahead and look at aluminum, it's 26.98 grams would equal 1 mole. Okay, so what can we do with that? You're saying, well, that's good, you know, what can we do with that? Well, here's the deal. Let's say that I have a balance. And on that balance I put, let's say, 5 grams of aluminum. What I can do with the number 26.98 and 1 mole, I can go ahead and count atoms now. Because 1 mole is equal to a certain count or number of atoms. So what I can do is I can go, okay, 5 grams. What I'm going to do is use this information here to set up my conversion. And then what I'll do is I want to find moles of aluminum. So I'm going to go ahead and put grams of aluminum down here. Now why do I put grams of aluminum down there? What I want to do is I want to make sure I cancel out grams. So that unit is not present in my final answer. And then up above in the numerator, I'm going to put moles because that's the unit I want to end up with. So then I come up here and I go, oh, That one's moles. And what goes down here is the grams. So for every 1 mole, I've got 26.98 grams. Right? So when I go ahead and divide, that's a divider. I've got less than a mole. So I go 5 divided by 26.98. And that's 0.19 moles. So I got about a fifth of a mole. 0.2 would be a fifth of a mole. Right? How else can I use that? Well, what I can do is I'm going to go ahead and erase this. What if I want to go to grams? You know, so if we're going to use this top example for that. So let's say that we look at nitrogen. And on nitrogen, I want to go figure out number of grams. So let's say I have 0.25 moles of nitrogen. Okay, so then 1 mole of nitrogen is equal to 14 grams. So down below, remember, I'll just write the same unit and symbol as I have up here. And then what I'll do is I want to go to grams. And I know that for every 1 mole, I have 14.01 grams. And then when I multiply that out, then that will give me the number of grams. So I can go ahead and figure out how many grams I would get if I had 0.25 moles. And that would be 3.5. So I'd end up with 3.5 grams of nitrogen. Right. So what I could have you do is I can give you 3 problems, and then you can go ahead and push pause. Once you hit pause, work through the problems, then I can show you the answers and the setups. Okay, so here's your 3 problems. And so off to the side, I'm going to go ahead and put what the periodic table says, how many grams it would be off the periodic table per mole. For sodium, it's 22.99. One mole. For chlorine, it's 35.45 grams is equal to 1 mole. And for helium, it's 4.01 grams is equal to 1 mole. With that information, go ahead and make your conversions. You can go ahead and push pause, do your conversions, and then I'll have the setups. Okay, so here are your setups. 100 grams divided by 22.99 gives you 4.35 moles. With the chlorine, you multiply, get rid of the moles of chlorine, and you end up grams of chlorine, and it's 62. And then you got grams of helium, get rid of the grams of helium, go to moles of helium, you got 5 moles. So those are problems at dealing with grams to moles.